Hello everyone and welcome back to Stationeers. Okay so I think in this episode I would like to work a little bit more on this weather control chip. Basically, yeah, I have imported it from the previous playthrough and, well, I think I can make it a little bit better. So, first things first. I have given up on the idea of using klaxons because klaxons don't really have the range needed to, cover a big area. But thankfully there is another way of alerting us when we are far away from the base. And that is, well, you know what? Instead of telling you now, let me just quickly try to put it together. First things first. To make this work, we will need two things. One of those is going to be a logic transmitter. So for this one we need some silicon as well. Also the suit can go in here. So silicon. Give me one of these please. And then we will also need an advanced tablet. Okay then. So start printing that one as well. Now, how do I explain this? Basically this transmitter will be connected up to the advanced tablet, and we will use, well, basically whatever we write to this transmitter will be replicated on the advanced tablet, and that way we can control what the tablet does. And that is how we will make sure that we can actually get alerted if we have a storm coming in. Because, well, the tablet, there you are, the tablet can, well, make sounds, and that is how we will be alerted. So, first things first, this guy, you will inherit everything from the old tablet. It has been a long time coming because we really should have done this upgrade a bit earlier, but you know what, better late than never. There, and this guy also can accept 2 cartridges, so you know what, let's just have the network analyzer in, because that is the other cartridge that we are using the most. Okay, so we have everything, and now we just need to wire up the logic transmitter and we can start coding. And this time around I think I will actually not code in a time lapse. I think I will actually just code well, live, because you know what, we haven't done a dedicated coding episode before, and I think maybe we should have one right now. So the logic transmitter, you will be in passive mode, not active mode, and you will be hooked up to the advanced tablet there and turn on. Now, as I said, we will not use the klaxons, so device 4 and device 5 will not be set to the klaxons. We will only have device 4 set to the logic transmitter. So just for a little bit turn off. As I'm cycling through, I don't want the chip to do anything untoward to, on other devices. So we need the logic transmitter. In fact, you can turn on now. In fact, we can name the logic transmitter to be the advanced tablet logic transmitter. Okay, so it is correct. Well, one more thing I want to do before we get started on the coding. I want to replace these lights. Right now, well, they are not, all that nice looking, and I think if we used proper lights, it would be a bit better. Plus, the other problem is that, first things first, can I please pick this guy up? There we go. The other problem is that these lights are not visible from far away. Basically, if we move not even all that far away, they will be invisible, and that is not very useful. Okay, where can I put them? There. But We do have some lights that are a lot more visible from far away. We just need the dedicated light kits. I will make 2 of them. And some of the models will basically... Okay, no, print it out please. So some of these models will create a kind of a, I don't know, a halo sprite around them, and it is going to be visible as long as we have line of sight on the base location. One of these is, well, this one would be okay as well, I believe, but this round light. This one definitely works as I would like, because as I've said, even if the base is not drawn in the world map, this light's halo sprite is still going to be visible no matter where we are. Well, as long as, you know, it is not obstructed by terrain, but for example, if we are on top of that volcano, it will still be visible. Anyways, this one as well. Although, you know what, before I install these, you come down, maybe I should paint them. Now we have a white spray and I believe a gray one. Yeah, I don't think any of those colors would fit what I have in mind. I think I would like to have these lights to be red. So yeah, let's just quickly print out a red spray can. So there you go. And can you please give me a red spray paint? There we go. Okay, obviously for this to work, we need to suit up because I don't want to pollute the atmosphere of the base. So there, visor down and cycle. In fact, while we are outside, we might as well install this, but first, open, then paint, no, there, and then I will install this guy right here. So jetpack, and as I said, I would like to use the round light, this one. Okay, so if it turns on, it gives off a faint red glow, but if we move far away, it should give off a... there it is. That red kind of a halo or glow sprite that is going to be visible from very, very far away. I think even if we move to that mountain, it will still be visible. But anyways, that's fine. Now we just need to name it. You are going to be the outside weather alarm light. Sure. Okay, now we can go inside. Oh, and it's still turned on, and it's, you know, reflected in the window. Anyways, you can go here, and you are also red. Okay, and now we can start coding. So as I said, this time I will not do this in a time lapse, I will do this live. So you turn off, you go in the laptop, import, this is the current code, and pause. Now, as I said, we will not have klaxons, but device 4 is going to be the transmitter. So we don't need any of these lines of code anymore. But this one we still need because this is going to be the transmitter. There we go. And here the same. We don't need klaxon 2, but we do need the transmitter. Okay, now one thing I want to change is that right now we have a storm incoming section and a standby section. But I still want to have a section where we have the storm actively going on. And I think I will just simply have a branch less than 0. So yeah, we have a greater than 0, an equal to 0, and now we have a less than 0. So storm time, and this is going to be the storm active section. Sure. And I suppose we will just put it in between the incoming and the standby mode. So here we will have the storm active section. And obviously at the very end we will jump to the start. Okay then, so let's do the display first, I suppose. So right now we are just displaying the countdown to the storm start, and here we turn off the display. So that's fine, but I think we can make it a little bit nicer, I think. So let's start here. What I had in mind is that, okay, for the storm incoming section, I would like to have a set, okay, need to use this string for a couple of times. So here I want to set a color for the display, because right now we are just using green and that's not very, interesting. So what I had in mind is that for the countdown we will use yellow. For the active storm we will use red, and for the standby mode we will use green. So red, green, yellow. So here we just need to set a color on the display, and that is going to be, what is it again? Display LED. So for the color we have all these options, and I'm looking for yellow, which is 5. Okay, so we need to set that value to 5. But there is one more thing we need to set here, and that is the mode of the display. That is because right now we are displaying numbers, and I believe that is the default set mode of the display. So we have this mode, and we have these modes on the display right now. Default, that is basically it will display a number or a percentage, a power output. Basically it will put a watt or kilowatt at the end. Then we can display the temperature in Kelvin, Celsius, or even Fahrenheit, or we can have distance in meters, or the amount of credits we have, or anything like that. It is basically, we can set the mode what we want to display, and later on we will display strings. But right now we want to make sure that once we are in this section of the code, we are displaying just a number. Although maybe we should just display seconds. No, it's fine. Let's just go for default. Although, no, let's just display seconds. I want to see what happens. So set it to 7. So set W display mode to 7. Okay, so we set the color, the mode, we turn it on, and we set the amount of seconds we have left until the storm arrives. And we need to jump forward 1, 2, 3, 4, 5 lines. And there we go. And speaking of the remaining time until the storm arrives, if you remember in the last episode, we had a not whole number being displayed. So it was, I don't know, 88 point something something. And I only want to display the whole number. Thankfully, it is fairly easy. All we need to do is round it. And thankfully, we just have a very simple round argument that we can use. So we are going to round the storm time. So basically we will write into the storm time register, and because we are rounding the storm time register. So this is the original time, and this will overwrite this one. I hope it's self-explanatory. So also round 0, this one should be storm time. There we go. Now it should be slightly easier to read. So this section of the code is now okay. Next, let's take care of the storm active part. Here we need to set the color again and the mode again to something else, and we need to... I mean, do we need to have this display on? You know what? Once we actually reach the point where the storm is active, we will not enforce the display to be turned on all the time. Here, it obviously, we will come out of this mode, so it will be on, but if we have to, we can turn it off if we want to, it's fine. And we need to set a setting on the display. So first things first, the color. As I said, I would like this one to be red. So that is going to be 4. So set the color to 4. And then the mode. I want to display a string. And that is going to be mode 10. So that's mode 10. And here we can set a string. All we need to do is str, then start a bracket, and then quotation marks. And inside those quotation marks, we can write characters that will be displayed. And I would like to have just display storm. Unfortunately, the display we are using is not very wide, so we have a very limited amount of characters that we can use. So need to keep it, you know, very, very brief. And I think that is pretty much it. Yeah. So theoretically, this will turn the color red and it will display a message on the display that it says storm. In fact, maybe we just have a couple of exclamation marks as well. Okay, so we need to jump forward 1, 2, 3, 4 lines in case we don't have the display set. But you know what? This is simply for the benefit of other people, not for us, but since we have this one, we might as well use it. Okay, we will have a couple of other stuff later in this section, but that will come later. Here, basically the same thing. So let's just copy all these and copy this one as well. Now, the message here is not going to be obviously storm. It's going to be clear, because, you know, we have no storm incoming, there is no active storm, so the weather is clear. And the mode is still going to be 10, but the color, as I said, I would like it to go back to green, so that's going to be 2. And we need to jump forward 4 lines if we don't have the display set. So that is now okay. So the display section of the code should be good to go. In fact, we can confirm and export the code. And if you slot it in and enable it, then that display, you know what, let's just turn it on, because we are not enforcing the on. So if I turn this housing on, then that display should have a white clear on the display. Okay, what is the problem? It is line 35. Line 35, what is happening there? So 35, set display setting, string, storm. Storm active, that is not happening. So why are you trying to do that? Storm active. It's only if it's less than 0. Maybe we need to reset it or something. So export and turn it on. We have that one set, weather station, weather display. Why are you... It says invalid string length. Oh, okay. It's too long. Well, in that case, don't have the exclamation marks. Or exclamation points or whatever. So here, just write storm. That's it. Yeah, it should be okay now. So confirm. Export, in you go, and no longer complaining, and it does, okay, not white, green. So it is working. Good. So next up, let's take care of the logic transmitter next, I suppose. So once again, you turn off, go back in here and edit and pause. So how do we do this? As I said, this logic transmitter is now, yeah, I did set it correctly, right? So yeah, it is hooked up to the tablet. So now it is communicating with the tablet through radio waves. So no matter how far we are, no matter if we are obstructed, this guy is now connected to the tablet all the time. So no matter where we are on the map, we will get an alert sound if we have a storm approaching, once we are done coding, obviously. So let's go ahead and try to figure that out. So pause. Let's start right here, storm incoming section. So in the transmitter section, what we need to do is basically, as I said, it is mirroring what is happening on the tablet. So whatever we send to the transmitter will be sent as it is to the advanced tablet, and it will be executed. So what we want to do is that we want to turn on the tablet if we have a storm approaching, because otherwise the sound will not play. So first we need to set the transmitter on value to be 1. So if we have a storm approaching, it will turn on the tablet, and then set the transmitter, and on the advanced tablet, this guy, we have a sound alert function. Basically, it will receive a value for one of these sounds, and it will play it. And I think it's pretty obvious, I want to have the storm incoming message to come through, so we will set it to 18. So what we need to do is have the sound alert to be set to 18. And I think that's pretty much it. So need to jump forward 1, 2, 3 lines, and that's going to be the end of this section. We will work on the lights later. So that's fine. And okay, so this is only important when we have a storm approaching. Once the storm is here, it's no longer relevant, but on the other sections we don't want to enforce the turning on of the tablet. So this is not going to be used anywhere else, but we need to use this one because also the BRDNS check, but only this time is 2. We still need to do this one because, well, if we just leave it here, it will keep playing the sound no matter where we are. So we need to reset this one, and that is going to be 0 because in the other sections we don't want to play any kind of sound. So here it is going to be 0, and the same here. Copy this one here and 0. Now I want to test this one. So right now we have no storm approaching, but I still want to test this. So let's just set it to 1. Whatever that sound is going to be alarm 2. So no matter what, now we should get a alert sound coming through the tablet. So confirm, export, in you go, and let's take a look. So the tablet is off now. We turn it on. Wait, it comes through if it's not on. No, it's off now. It's only coming through if the tablet is on. So what was that before? Whatever. Okay, it's working, that's what's important. Okay, so it is working. Now you come out once again, and now we just set it to 0 because obviously this was just a test. Normally this would be 0. So confirm. And now, so we are done with the display, we are done with the alert sound, and it will alert us no matter where we are. By the way, the incoming storm, this one sounds like export
storm incoming.
Okay, for some reason it still plays if we freshly slot in the IC chip.
Storm incoming.
But otherwise it only plays if we turn on the tablet.
Storm incoming.
But anyways, that's what it sounds like. Okay then, so you come out, edit, and from now on this is going to be 0 here. Okay, now the lights. Now this is going to be a bit more complicated. Basically, what I had in mind is that I still want the light to flash when we have a storm incoming. But when the storm is active, I want the lights to be turned on continuously, and on standby, where basically we have no storm coming, when the weather is clear, I want them to turn off. So these are already correct. So we don't need to change these, that's fine. But here I will simply add this section, but these will be set to 1. So when we have storm active, these lights will be on no matter what. So basically they will give us a bit of a mood lighting for storm time. But here, this is going to be a bit more interesting, hopefully. So what I had in mind is that they will go basically turn on, then turn off, then turn on, then turn off. So it will create a kind of a alert flashing light, but not as annoying as the rotating lights. So first things first, just delete these lines for now. And what we need to do first is to load the current on state of the device. So we are using R0. Let's just use R1, it's fine. So R1, I will not name this register. We are only using it here and it should be self-explanatory. So we are dealing with the device and we want to load into R1 the current state of the on function. And now we need to invert it. But there is a small problem with this. You might be saying that, yeah, inverting the value should be fairly easy, just use the not argument or not operation and it will invert it. So R1, R1, that should be it, right? But for some reason it doesn't work here, I don't know why. You would expect that if this is 0, then it's going to be set to 1 and it will overwrite it. And if it is already 1, it will be set to 0 and overwrite it. But for some reason it's not working that way. In fact, I might as well show you. Set light on to R1. In fact, we need to jump forward 1, 2, 3 lines. No, sorry, 1, 2, 3, 4 lines. And this is going to be the same, but for our light 2 on the other end. There we go. So normally I think you would expect this to work, right? Because it says if a bit is 1, it becomes 0, and if a bit is 0, it becomes 1. So logically this should work, right? Let's take a look. So confirm, export, and did set these guys internal and outside weather alarm light, right? So in you go, and this guy, it's not doing it. I have no idea why. So you turn off for now. Although, wait, did we actually set these correctly? Because I think they are still the old values. Let me check. Ah, I didn't name the internal one. Anyways, Now the devices are actually set. So if I turn this on, it will turn off. It basically sets it to 0 no matter what. So yeah, it is not working as I was expecting. Alright, hydration. We shouldn't be wearing the suit, by the way. There we go. So, there is another way of inverting the values. It should be fairly easy. You come out and edit, pause. So, instead of using the not argument or operation, what I will do is set if equal to 0. Basically, if R1 is already 0, then it will become true, so it will be set to 1 and it will overwrite R1. But if it is already 1, then it will be not true, so it will be overwritten as 0 and written into R1 again. I think this should work. So here, set equal 0. And now it should be okay. So confirm, export, and there, and now it should actually cycle the light. No, it does not. Why? Oh, right. That is because we are right now doing the standby mode. I was coding the incoming storm. Okay, we need to copy this into this section of the code to actually test it. So I will do it for light 2. So we need 3 lines. Well, at least I figured out. So here, copy this one to here. Then this one. Oh, almost. This one to here, and this one to here. Okay, finally. Surely this will work, right? Export, slot it in, and if I turn on, the light should go on and off. There we go, finally. Okay, so it is working, but I think it is a little bit too fast. Tell you what. What if, instead of having a yield at the start, maybe just have a 1 second sleep there. So, confirm, export, and let's take a look. Yeah, I think this is a little bit better. It's less annoying and it still does the job quite nicely. Okay, so we know it works, so we don't need to change it in the incoming section. So you turn off. Let's just put it back to 0 on the standby mode, and that's going to be it. So this one can be deleted, and here we are setting the light to be turned off. There we go. So I think this weather code is quite alright, all things considered. We have rounded the countdown to whole numbers. So now we are, not dealing with not whole numbers on the display. And speaking of the display, on the incoming section it is yellow, it is only displaying numbers and only displaying the whole seconds on the countdown. On the, let's pause for a second please. On the active storm section, it will display a very angry red storm string on the display. And on the clear section, or the standby section, it will display a nice friendly green clear message on the display. And there we go. And on these two sections, we are no longer enforcing the on, so it will be turn offable. There we go. The transmitter, on the storm active and the standby mode, it will not submit any kind of sound, but when the storm is actually incoming, it will turn on our tablet no matter what. Even if the battery is low, it will still be forced to turn on, and it will sound the alert sound. So no matter how far we are going to get the message. And the lights, they will flash when the storm is incoming, so we know this is actually working. So light 1, light 1, light 1, light 2, light 2, light 2, those are correct. And so they will flash when the storm is incoming, and they will be set to be on continuously when the storm is active. And you know what? Not too bad. So the BRDNS checks appear to be correct. Yes, 3 lines, jump forward. 1, 2, 3, 4, 1, 2, 2 and 2, that's fine. And yes. You know what? Not too bad. Right. Okay, confirm. Export. And now we are done with this code. Okay. I think this will do quite nicely. Okay. Let's celebrate by drinking. And let's eat that potato. Although I don't think we will eat the whole thing, but eat as much as we can. And there we go. Okay, next up. Let's take care of a very important thing, that is the filtration alarms. Because, well, these filters not last forever. And I suspect that the filter that is refilling this pipe all the time, I suspect that guy is going to be pretty run down by this time. So I think we need to check on that. By the way, how are you? Yeah, you are alright. In fact, the base is... Exactly, okay. The oxygen content of the base is 19.8%, which means, and the pressure is up to 100 kilopascals, which means that the filtration that is, filling up the oxygen is working as intended. Very good, because it stopped filtering of the oxygen at 20%. And we are below 20% because we have refilled the CO2. So there we go. It is working. Good. Okay, so as I said, the filtration refilling this pipe should be pretty close to the depletion time now, so we need to check on that. And I think we can use these flashing lights as the alert to make sure that we know when we need to switch out the filters. So yeah, let's go for it. The suit itself is okay. Alright, let's go for it. We need to take care of this right now. Let's take a look. So, as I've said, I suspect that this guy should be running low by now, so 56% and 0. Oh yeah, definitely. We need to switch these guys out fairly quickly. So, this is basically the perfect test case for this code. For first things first, I will put this light here, because it will need to be visible from the inside. If I put it here, it might not be as visible as I would like. So let's just quickly hook it up. And there. There we go. It is now hooked up. And don't forget to name it. So this is the coolant refill filtration. So this is going to be the coolant refill filter alert light. Very verbose, but it's okay. So let's go ahead and turn this guy off now. Take out the laptop. There. Open. The chip goes in here. And what are we dealing with? So import. So right now, oh, very good. We don't have any extra devices set. So here we can have the alias and alert light as device 0. And I think I will just set this up at the very end of the code like this. I will leave a single line of separation, so, you know, we separate that the different parts of the code. So the way this works is that we will need to read the contents of these slots on the filtration. And that is going to be done with the ls function or command or whatever. Then, well, we are using up to R4. You know what? Let's just use R5. So we need to put into R5 from the filtration, and we need to select which slot. I believe they go from 0 and 1. Yeah, I think so. So 0, but let's just make sure. So filtration U, and you should have connections, logic slots, no. There we go. Slots 0, 1, and the chip would be number 2. Okay, so yeah, 0 and 1. So we are reading slot 0, and we are interested in the quantity value, because this is the basically the remaining durability of the filters. Now the problem is that it goes from 0 to 1, I believe, but it is not 0 or 1. It is going to be 0.55, 0.72. It can be any kind of value. It will only show as depleted at 0. So we need to make sure that we are only showing the alarm if it is as 0 at least. So tell you what, set equal to 0, I think should do it. So equal to 0. So if R5 is equal to 0, then set that register to 1. So R5, R5. Okay, so if the filter in slot 0 is depleted, then it will be, the quantity will be 0, and if it is 0, then just override the register with a 1, because we will check that later. Then do the same for the other filter. So let's just copy this whole thing there, but use R6 as the register and check slot 1, and then do the same kind of check but for R6. There we go. So now we are checking both of these filters, and if any of them are depleted, their respective register will be set to 1. Okay, and now we just need to make sure that we are actually, you know, checking, I think a simple OR operation should do it. So if either of these are 1, then we want to, let's just use register 7 for this. So if either R5 or R6 are set to 1, then R7 will be set to 1. Let me just make sure. If either bit is 1, the resulting bit is set to 1. If both bits are 0, the resulting bit is set to 0. Yeah, okay. That sounds good to me. And then we will use R7 to set the, where is it? The alert lights on setting, and that's it. I think this should work. But thankfully we have the filtration already depleted, so it should be fairly easy to check. So confirm, export and slot it in. We did set the light right. No, not yet. So this was the coolant refill alert light. There we go. So since this one is already depleted, if we turn this guy on, the light should come on. And there we go. It is working. Now we need to check. Thankfully we have some CO2 filters right here. So if I replace this one, the light should turn off. It does. Okay, so this slot works. Let's check the other one. So we have this empty filter right here. If we switch this one here, the light turns on. Perfect. Pretty much perfect. And if we replace the filter with a good one, the light turns off. Okay. In fact, you know what? Let's just leave brand new medium filters here so they will last a bit longer. And I will replace these once we get back inside. Okay. So now we know when any of these filters are depleted. What about you guys? 98%, that's very good. So these have not been used a lot. What about you guys? You are, wow, both 100%. You have not been used a lot. What about you? 97, yeah, you will last a long time. So the problem is that if we take out the laptop, edit, pause, the problem we are facing right now is that we can only select a single line at a time. As you can see, the cursor is up here and we are only highlighting the line that we have started the selection on. So we cannot select multiple lines, right? Even shift, no. Control, no, doesn't matter. We can only select a single line. And that makes it a little bit hard to copy paste this whole setup. So for every single filtration, we will need to write out this code every single time if you want to update all the codes. That's going to take a while, but it's not too bad, but still far from ideal. Anyways, I will try to remember to do this maybe once every episode. I will fix one of these filtration units, but not right now. That would be a bit much. Anyways, how is this one, by the way? Okay, so we have 19 liters of water in the base. I think that's a bit less than we had before. And we have... we have none here. We have millimoles of water here. You know what? I think I will change the amount of steam we are inputting into the cooling pipe. So yeah, you first turn off, and then go in there, import, edit, and pause. So right now we are only inputting until we reach 1 megapascal. Let's go for 2 megapascals instead. But I don't want to change the temperature. I think the 100 Celsius is still a relatively acceptable threshold. Yeah, I think so. And you know what? Since we are... No, I will do it once per episode. Don't get too carried away. Export and put it back in and turn on. Okay, so now we are inputting 2 megapascals worth of steam. That's fine. These should still work okay, but it is now daytime. Let's check the pressure on this one. It is 2.6, so the threshold was 1 megapascal. And we have increased 1.5 more, but it is still increasing. I think I will increase the threshold on this guy to maybe 1.5 megapascals. I think that should be acceptable. If it starts complaining, I will just lower it back down, it's fine. Okay, I think we have about 5 minutes left on the recording. By the way, how are you? 30 megapascals, okay. And you are cold? Yes, you are cold. Okay, quickly trade this away. So input, you, sell. Quick, there we go, 19, sell. Okay, close, and we don't have enough left, so stop, and there we go. Okay, I will just let this one run, it's fine. I will trade away the... I will basically buy the rest of the water once we are done trading. By the way, we still have 33 liters of water that we can buy, but we will not have enough money to buy all of it. So we can make... Yeah, basically we can make one more trade. After that, this guy will become completely useless to us. But we have one more trade that we can do. By the way, how is this filtration? 98. And that one is actually empty. Okay, in that case... Yeah, let's put this small filter in there. And by the way, how are you? 21%, oh. And 100. Okay, it's not a problem that this filter was used so much. We will stop doing this after we are done with the last trade anyway, so it's fine. I am not sure if I will break this whole thing down, but it will be definitely turned off at least. Anyways, quickly vent out the waste. And the oxygen need to be switched out as well. So you switch out and the suit can go in the... whatchamacallit? The airlock. There we go. Okay, so as I said, I think we have about... Okay, 3 more minutes until we reach the 1 hour mark. What if we expand the power network at least a little bit? Because yes, I did notice that we are not really making enough power now. Mostly thanks to the water generation, and couple that with the voltage filtering, yeah. Even with the extra solar panels, we are not quite there. So let's just place a wind turbine. So wind, and instead of using these small upright wind turbines, let's use a proper horizontal axis wind turbine. Sure, these are going to be big ones. So we need copper, steel, and electron. So copper, steel, and electron. How many can we make? We can make 4 of them. Okay, I will make 1 for now. What do we need to finish them? So wind turbine, the big guy. To build this one, we need 5 steel sheets and 5 cable coils. Okay, everything we should have. We have the 5 cable coils and the steel sheets right here. Okay, we don't need the paint can. The flashing light, I will leave here. I will try to remember to, you know, do these kinds of filter setups again in maybe at least once per episode. That's fine. We can eat the rest of this potato there. And yeah, I really should sort this one out, but these guys will last a little bit longer, so it's not urgent, but I would feel better. Anyways, alright, speaking of filtration, let's just quickly make sure. So yeah, we have this filter is empty, and this one, you go there, and we need at least 2 more. I think we will have a warning, so we will know once it becomes urgent. This will last a long time still, so it's fine. So anyways, wind turbine. Now, to hook this guy up, we will need a couple of heavy cables. So, heavy cable, oh sorry, need to turn it on and start searching. Heavy cables, need some gold as well. There, just print out a bunch. Now I don't remember, do these need support? I think they do need support. Right now it is blocked by the ceiling, but yes, they require a frame to be supported. Okay. Well, in that case, we have these 4 steel frames right here. So it is good that we are no longer using them to put into the corners of the new base. And this should be enough cabling. 1 more. And done. Okay, this should be enough. You can turn off, and these heavy cables should be able to take the load even if we have a storm, so theoretically it should be fairly safe. Okay, let's go for it. First things first, suit up, visor down, and cycle. Okay, where do we want to place these guys? The problem now is that we will have the black hole going more around that part of the sky. I think I will have it, I don't know. No matter where I place it, it's going to be blocking the... right. Let's just have it here for now. Okay, so you can go right there. And this one thankfully doesn't require data, so you can be facing that way. So, we need the steel sheets. There we go, that's one. And then the cable coils. So there, and I believe it was the screwdriver. There we go. And it is up and running. Okay, now you just need to hook it up, and that's it. So you go ahead and do that, and the cable cutters. There we go. Now we have a bit of extra power. By the way, what is the current generation? There, and switch over to the network analyzer. And currently we are generating 200 watts thereabout. It's not too bad, but it could be better. So I think in the next episode we will print out the other 3 wind turbines. Right. Okay, I do believe we need to stagger them. So we cannot place another one here. We need to put the next one here, and then here, and then so on and so forth. So yeah. I will reclaim this one.
Hydration critical.
You. So we will have the next one. I believe here should be okay. And then there. And then there. Yeah. The bad thing about these wind turbines is that they require a lot of wiring. But at least we have this one now. And if we have a storm, the guy will create a lot of power. Anyways, we didn't really have any time lapses in this one, and we are over time now, so I think it is time to say goodbye. All that is left to say is that thank you for watching. If you liked the video, you can leave a like, leave a comment, and maybe subscribe to the channel if you want. If you would like to support me a little bit more, you can do so by clicking the join button and becoming a channel member, which will give you an early and ad-free access to these videos. Once again, thank you for watching and thank you very much for your support. I will see you in the next one. Thank you and goodbye.